Welcome to the another video of the series NestJS tutorial from scratch. In this series, we are building microservice using the NestJS. You can check the link of the playlist in the upper right corner. We have already seen how to create the basic task service using NestJS and MongoDB, and authentication microservice using JWT and Postgres database, and also custom mail microservice, which uses this microservice, the authentication microservice. You can check the link of this video also in the upper right corner. And we also deployed one microservice in render.com. So today we will learn how to create GraphQL microservice using NestJS and MongoDB. So let's get started. So my GraphQL microservice project structure will be like this. If you see, we will have the src folder, which is the root folder, and inside this we will have the main.ts entry point of the application, and we will have the app module.ts root module of this application, import the other modules and setups of the GraphQL, and schema.jql will be auto-generated from the book.resolver.ts, whatever we will define here. And there will be the books directory where we will create the books.graphql.ts, which will contains the GraphQL types, queries, and mutation for the books. Book model.ts, model for the application, and book schema for the books used for the database like MongoDB. There will be the helper functions module, book related functionality imports providers will be there, and the resolver to handle the GraphQL queries and the mutation for the books. So let's get started and create our NestJS application. So I will go to this directory, and inside I will open the Visual Studio Code. So I will open the terminal, and here I will put the command code dot, which will open the Visual Studio Code in this current directory. Next, I will put the commands to create a NestJS basic structure. So the command is the nest new GraphQL MSVC will be my project name, and I will put enter. So basically, NestJS is a progressive Node.js framework for building efficient, reliable, and scalable server-side application. NestJS leverages TypeScript and combines elements of object-oriented programming and the functional programming and functional reactive programming. So it will take some time to create the basic structure of the NestJS. I already explained what is the prerequisite to install the NestJS and how to create the NestJS with a basic task service. You can check this video link in the upper right corner. So here I have to choose the npm which I am using, a node package manager. So you can see it successfully created the project GraphQL MSVC, and now I will go inside the project GraphQL MSVC. So if I give you the quick introduction of the GraphQL, GraphQL is a query language for APIs and server-side runtime for executing those queries by providing a complete and understandable descriptions of the data in your API. It allows client to request only the data they need, making APIs more efficient and flexible. To create the GraphQL microservice, we need some basic libraries and node packages to be installed. So I will install them. The packages are first the Apollo server, Apollo/server. So basically, Apollo/server is a package provided by Apollo that helps set up a GraphQL server. Apollo server is an open source community-driven GraphQL servers that allows you to quickly create a GraphQL API. It's built to work with many popular JavaScript frameworks and libraries. Next, to integrate the NestJS application with the Apollo server, we need the @NestJS/Apollo package. Next, we need the @NestJS/GraphQL package to integrate the GraphQL with the NestJS application. Next, we need the @NestJS/Mongoose package. This package integrates Mongoose with NestJS, making it easier to use Mongoose module. and schemas with the NestJS application. Next, we need the Mongoose package. Mongoose package it's an ODM or object data modeling library for MongoDB and nodejs, providing a straightforward way to interact with MongoDB. And next, we need the GraphQL NPM package, provides a GraphQL query language and its runtime implementation for building and consuming GraphQL APIs. Next, I will press enter to install those packages in our project. The packages are successfully installed. Next, I will go inside our project directory. You can see we have the src folder, and inside src we have this app module.ts. So in this app module.ts, next I will configure to set up the GraphQL servers using the Apollo. So in this import sections, I will import the GraphQL module. So GraphQL module. So GraphQL module for root. So this will take the configuration like the Apollo driver configuration. So Apollo driver config. Next, I will put the Apollo driver. So here the driver will be the Apollo driver. And next, I will have the auto schema file to ensure the GraphQL schema is automatically generated based on the GraphQL resolvers and type, simplifying the development process. So auto schema file will be my path where the GraphQL file will be generated or schema will be generated. So I will take the process.pwd or cwd to current working directory to take, and next I'll create the schema file inside the src / and file name will be the schema.gql. I will quickly fix the lint error. The command is npm run lint. I quickly fix the lint error. The command is the npm run lint. Here the join needs paths to be specified. So I will quick fix these things to importing path. Next, I will remove the controller. I don't need any controller here. And the providers, I will create a simple resolver to check if it's automatically generated the schema.gql or not. So I will create a for resolver. So I will create here the f.resolver.ts, and here I will use the resolver decorator. Resolver and export class for resolver, and it will contain the query. So basically the resolver are responsible for handling GraphQL queries and mutation. When a client makes a request to the GraphQL server, the resolver is a function that processes the request and returns the response. Here I will take the query decorator to be defined to the a query field in the GraphQL schema. It specifies that the method will handle query for a specific type. I will specify the type string, it will return, and inside I will put method say hello, which will return string, and it will return hello world. I will quickly fix the lint error. Here you can see the query is not defined, so I will define the query. And here it's complaining the app controller is defined but never used, so I will remove the unused import. Next, I will start the server. The command is here we have this npm run start to start the server, and if you want to start the server in watch mode, you can run the command npm run start:dev. It's complying the foo resolver. It's not imported in the app module.ts, so I will import it and I will save. You can see the GraphQL Microservice NestJS application started and it created the schema.gql file. This file is automatically generated and here we have the type queries, here hello string. Next, I will go to the app module.ts and here I will import the setup that will dynamically connect the MongoDB using the value from the configuration. So first I will create the .env file in the root directory, which will contains the connection string of the MongoDB database. So .env, and I will take the config variables as the MongoDB URI. So, and it will contains the connection string MongoDB / localhost 0.0.0.0 port of the MongoDB, and I will put the database name is the GraphQL demo. So the prerequisite things are the MongoDB should be installed in your machine. You can check my video how to install the MongoDB and how to access the MongoDB using the MongoDB Compass tool. So I will open the MongoDB Compass tool. I will connect with the localhost 27017 and here I will create the database. The database will be the GraphQL demo and the collection I will do book and I will create the database. Next I will go to the app module.ts. Next I will initialize the configuration module, which will be used to manage configuration. So config module.forRoot, and here I will define the is global true to use the config variables entire the application. Next I will have the mongoose module. So mongoose module to configure the mongoose connection asynchronously. So I will take the for root async. Inside this I will import the config module to take the MongoDB URI from the .env. So I will import config module. Next I will use the use factory function that will return the configuration object of the mongoose, and it will also called asynchronously to allow the dependency injection. So use factory : async config service config service. I will import it. And here I will define the URI from the .env config service .get. I will take the variable from here. Next it will take the connection factory. Connection factory, where I will define the different events for the connection. And I will have the connection.on connected. When the MongoDB will be connected, it will print the message as the MongoDB connected. And I will take the logger here. Const mongo logger new logger MongoDB. I will import the logger. And here I will put the Mongo logger.debug. MongoDB connected. Here it's comma expected, so I will put the comma here. I will have the other events as well, like the error. On error, I will print the error if there is any error in the connection. So error, and it will print the Mongo logger dot error, MongoDB connection error. And will print the error. Here I am getting the error, the get not defined, the config service is not config service.get is not able to recognize, so I have to inject the config service inside the mongoose module. So I will inject config service. Now the error gone, but the unable to connect to the database. I have to look into this error. Here the use factory need to, or connection factory will return the connection. So here I will return the connection. Let's see. So here the URI, here it's not able to get the MongoDB URI from the .env because we didn't restart the server. So the .env contains, if we change anything in the .env, it will not restart the server. So I have to restart the server. So watch basically not detecting the changes of the content of the .env. Still I am getting the error, unable to connect. I need to debug it. Got the error at the .env. You can see we have the outside of the directory. We have to move it to the root directory. So here I move the to the .env, and next I will restart the server. You can see the next application is successfully started, and it should print the message the MongoDB connected. But let's add this line, connection dot dollar events, next underscore events dot connected. Now you can see it's printing the message MongoDB is connected. So the MongoDB connection is successful. Next I will create the books module. So I will open another terminal here. I will go inside the GraphQL MSPC, and I will insert the command to generate the books module, NestJ module books. It will create a books directory, and it will create the books module.ts file inside it. You can see it's created the books directory. Inside we have the books module.ts. Next I will create the schema inside the books directory. So I will create a directory schemas, and inside schemas I will have book.schema.ts. So it will be used by the MongoDB. So it will define the schema of the books collection. So first I will export the TypeScript type name, book document. So export type book document equal to book and document. Next I will define the book class. So I will use the schema decorator here. The schema will contains the version key that will be false, and the collection name will be book. So if you see the compass, we already created this book. So here I defined, I will export class book. Next I will define the prop decorator to define the properties of the mongoose schema. And in these fields, this book fields will be required to, it will be underscore ID field or the object field. So I will put the required to, and it will be underscore ID colon string. Next I will have the required to title. Title is also required fields, and I will have author and the year, which will be a required false. That will be nullable, but the other two will be not nullable. Author and year. Year will be the publish year. Prop cannot find, so I have to import it. NestJS mongoose prop schema, and the document I have to import from the mongoose. Import document. Next I will export the book schema. I will export const book schema. I will use the schema factory here. Schema factory dot create for class book. Dot method. I will take the toJSON method. And it will take the callback function here. Here I will take the object this dot to object, which will converts the mongoose document instance into a plain JavaScript object. And next I will have the object dot underscore ID. I have to convert it to the string, the object ID to the string. So it will be the obj dot underscore ID dot to string. And next I will return the object. Sorry, I take here the arrow function. Arrow functions not support this, so I have to take the conventional function. Here the type of book is not assignable to the type string. So here I have to define the string. I will quickly fix the lint error. And I can see there is no error here. Those are the lints error. So it's compiled successfully. So it successfully created the schema file. Next, we will configure the mongoose to work with the specific MongoDB collection book. So I will go to the books module.ts, and here I will import the books collection. So import, sorry, imports will takes the mongoose module. Mongoose module dot for feature, and it will take the name book dot name, and I will also provide the schema here, book schema. Book schema. Sorry, the imports will be inside the module, so I have to put into the module. So inside module I will have this one. So mongoose module, it's not able to find it, so I have to import it. So you can see it's compiled successfully. The purpose of this configuration is to register the book model with the mongoose in the current module, the books module, and provide the schema definition for the book module to ensure the correct structure of the document in the MongoDB collection. And next, if I go to the structure, I have to define the book GraphQL.ts, which will contain the GraphQL types, queries, and mutation for the book. So I will create here the GraphQL directory inside the book GraphQL, and inside I will have the book.graphql.ts. Here I will define the GraphQL object type for a book. So I will use the object type decorator of the GraphQL. So this define a GraphQL type that matches the structure of your data model. And next I will export class book, and it will contain the field, define a field in the GraphQL object type. So I will use the field decorator, and here I can define it will be nullable or not nullable. So it will be nullable, true, and it will contain the ID string. And next field I will have the title, author, year. So nullable 2 will be title, author, and year. Year will be number. Let me quickly fix the length error. Next, I will define the GraphQL object type collection age cursor based pagination. Again, I will take the object type decorator, and I will export class collection age. And it will contains the field which will be type book. Each item of the collection, so it will be a node book, and next field will be the cursor, and it will be not nullable. So as it is the paginated result, so cursor will be there, which will represent the cursor for the pagination used to mark the position of the items in a paginated result set, allowing client to request subsequent or the previous pages. So cursor string, sorry, it will be type book, type Next, I will define the structure of a GraphQL type that will be used to describe the paginess and information in a GraphQL schema. So that will be the page, object type, and export plus page, and it will contain the field current size and the total. Field will be again nullable false, and it will be the current. Current will be the represents the current page number in the pagination context, and next we'll have the size and total. Size and total. So size represents the number of the items per page here. The size and the total will be the total number of items available in the dataset. So let me check the object type. Define twice. Next, I will define the GraphQL type for the response or the search results. At that object type export class page result or search result. Which will contains the paginess and information and the items or the documents of the book. So I will take that date field that can be nullable. It will be page and type will be page, and next I will have the field type collection age array, and it will be the ages or the items, which will be the collection age array. We defined the GraphQL response type here. Next, I will define the search input type. For the search input, I will use the args type decorator. So this decorator is will be used to accept the arguments in the GraphQL queries or the mutation. And here I will export the class search input. And the search input class will be as a GraphQL input type by providing the args type decorator, and it will contain the field nullable false page number, which will be number, and also the limit and the query that the user or the client wants to get the results, and the collection name. So that will be limit will be the number here, limit number, and next we'll have the query, which will be string. You can provide any Mongo query here to get the results, and next will be the collection name, that will be string. So our book.graphql.ts is completed. Next, I will create the model, book model.ts, book model for the application. So I'll create a directory inside the book, the model, which will contains the book.model.ts. And our book model will contain the title, author, and the year. Export class book model title, which will be string, author, and the year. Next, I will import this book model into the book module.ts. So here I will have the book model. Next, I will create the book helper function, book helper file, book.helper.ts inside our books directory. So book.helper.ts. Before creating the helper, I need to create the service to handle the business logic related to the book. Whatever the query will be there, whatever the client needs, so we will define inside the service. So I'll run the command nestjs service book, which will create the book.service.ts inside the books directory. Sorry, that will be books instead of book. So let me remove the book. So book service created. Here I will take the book model to work with in the constructors. Inside constructor, I will inject the model. Inject model dot name, and here I will take the private model, which will be the model book model, and I will also import the model here from the Mongoose. Next, I will have the method find count, which will take the query and return the results number. So it will return promise number. Return this dot book model dot count document, and I will pass the query. And next method I will have book service. Cannot find model book service in app.module.ts. I have to remove it. And also this one. So next method I will have the find by page for the pagination results. Find by page, and I will have the skip limit, offset limit, and the query, and it will return the promise book result. And I will get the result. Await this dot book model dot find query dot skip. I will pass the skip dot limit. I will pass the limit, and dot execute. I will execute this Mongo query, and next I will return result dot map item. I have to map it to the book item dot JSON as. I will fix the lint error here. Declare promise typo error. You can see it successfully compiled and also the lint error fixed. Next, I will go to the books helper.ts and I will create the helper function. So first we will provide the injectable decorator here, and here I will define the scope, and scope will be my request. So here the scope property controls the lifetime and the instantiation of the provider here, and the scope.request indicates that the new instance of the service should be created for each incoming request, and every time a request is made, a new instance of the service will be created and injected, and it will be discarded after the request is completed. Next, I will create the book helper class, the export class book helper, and I will use here the service private read only book service book service, and next I will have the method async find by page, which will take the search input and it will return the search results whatever defined in the GraphQL.ts file. Promise search result. I will first check the search input. If the search input is not defined, then I will return or show new bad request exception. And if it's provided, then I will put the operation into the try catch block. First, I will take the query here, const query equal to JSON dot parse, as it will be in the string, so I have to parse it into the JSON search input dot query. And next I will have the total count, const total count. Total count, I will use the service find count method, this dot book service dot find count, and I will pass the query. Next I will have the start cursor, the starting of the cursor, and I will calculate it. The start cursor will be the my search input dot page number -1 into search input dot limit. So basically the start cursor will calculate the starting position of the position in the dataset. So here I search input dot page number -1, actually it's create the pages at the 0 indexed for the calculation, and next multiplying with the search input dot limit, So it will calculate the total number of items to skip to reach the start of the current pages. So suppose my page number is 1. Next, it will calculate 1 minus 1, and suppose my limit is 10. Enter limit. Sorry, limit is 10. Next, 1 minus 1 into 10. It will start from the 0 index. Next, if the page number is 2, so it will calculate 2 minus 1 into 10 from 10. So start index will be 10. So it will skip first 10 and start from the 10. By this way, it will get the result. Next, I will fetch the results. So const results will be await this dot book service dot find by page, and it will contains the start cursor. It will take the input or the parameter start cursor, limit, search input dot limit, and query. It will return the collection age. So const ages collection age array, and I have to map the results. So I will so whatever results I will get, I will map it. Results dot map, and it will give me the. So if I check the find by page, it will give me the promise book array. So I will get the book here, and I will map it to the cursor, which will be my node dot underscore object unique ID, and the node will be my item. And for the page calculation, import the book and for the page calculation, I will have const page equal to current. Current will have the search input dot page number will be my current. Search input dot page number. I have to parse it into the integer. Page number is string, and if it's not provided, it will be 1, and size will be my edges dot length, and total will be my total count. Next, I will return the search result. Search result will contain the page and the edges. I will return page and edges. Edges dot length string is not assignable to type number. So let me find the year. Here we have the string, it will be number. It should be fine now. Still we have this error. Here it also will be number. You can see it's compiled successfully. Let me fix the lint error. So our book helper function is completed, or book helper file is completed. Next things, we have the book resolver to handle the GraphQL queries and mutation for the books. So I'll go to the book resolver.ts. So we don't have it. So let me create the book resolver here. So NestJS resolver. So basically, in the resolver method, the setup I will do that will allows the client to query for the books. So here is the resolver function using the search operations. So with the resolver managing the data fetching and the transformation logic through the book helper function. So I will use here the book helper function. So first, let me take the constructor, and inside constructor I will take the helper, book helper, private read only book helper, book helper, and next I will have the query decorator I will be use, which will returns the search results. Mark the search method as the GraphQL query resolver, specifying the return type. So here I will returns the search result, and here I will have the method search, and it will take the asked search input, which we defined in the GraphQL.ts, the search input, and we will pass to the helper function. We will return this dot book helper dot find by page, and we'll pass the search input here. I will check the debug log. Our args is not defined. I have to import it. And next, the search input also not imported. Search input is already imported. Here I have to define what will be the resolver. So it will be our book type. So here it's complaining query return search result, unable to resolve signature of the method taken when called. Type property descriptor is not assignable to the number at the rate query return search results. So here we have this query. Query will be from the GraphQL, not the common. This is not the HTTP query. So you can see it's this method, the resolver, is successfully compiled, but we have to import this in our module. I will go to the books module.ts, and here I have to import. Here I have to import the book helper. And you can see it's compiled successfully. Let me fix the lint error. The lint error fix here, it's not using, that's why it's complaining. Next, I will open the Postman, and I will hit this API endpoint /GraphQL to check our GraphQL API is working as expected or not. So here I will add request. Here my request will be the post request. So if you see the map slash GraphQL post, and my server is running is 3000 port. So if I check the server main.test 3000, so it will be the HTTP localhost 3000 slash GraphQL, and body will be the GraphQL, and here I will define the query, and inside query I will have the search function, and search will have the collection will be book, and next I will have the query. First I will put the empty query so that I can get all the results, and I will have the page number 1, and the limit I will put 10. Let me check once the GraphQL schema.jQL. So here I have the search, insert search. I have the page number, so it's small, so I have to put it page number, limit, query, and the collection query, page number, and the limit. And next I have page, which will contain page. I have the current size and the total, so I will have the current size and total. And next I have the edges will have, so edges, let me check the edges dot GraphQL. Edges will have the ID, title, author, and the year. So edges will contains the cursor and the node, which will contain the ID, title, next I will have the author, and next I will have the year. And so if you can see the schema is fetched. So if I hit the query, I will get the results. String cannot be a non-string value, so query I have to pass any string. So let me pass here string, and you can see it's fetching the results, current 1, size 0, total 0. So you can see we don't have any collection, we don't have any data here. So let me put the data here. So I will add the data by inserting document or the inserting JSON. So I will take the JSON from here. So I have this book data, and I will import it. Here I have some data. Now if I query, so I am getting the size 10, total 10, and I am getting the results here. So if you see, I am getting the result. Let me change the limit to 100, and you can see we have total 10 records. That's why it's not able to give me the 100 records. If I fetch 5, then I will get the size 5, and you can see the length of these edges, it's 5, and we have the cursor node, everything is here. And here I have 1, 2, 3, 4, 5. Let me go to the page number 2, and here you can see I am getting another 5 results. Let me go to the page number 1 and let me remove the underscore ID field, and I want to get only the title, author and the year. So let me grab that, and here you can see underscore ID is not present here. So in the GraphQL, whatever results you need, you can get exactly that results. So if you need the year details, so you can remove it and you can send it, and you can get only the title and the author. And also you can put the query here, like if I put the query with the title, so slash I want to filter by title, and I will put here the title like To Kill a Mockingbird. I just want to get this result. So let me grab this, and here if you see, I am getting only this one, To Kill a Mockingbird. And here, other than these things, you can do the filter, greater than, less than, whatever MongoDB query yeah, you can put here in the string format, and you can get the results according to it. It is the nice feature of the GraphQL API or the GraphQL microservice. Yep. So let me show you the another example, like I need a year here. So year, and I will query by the year, and here I will put, instead of this, I will put the slash dollar greater than equal to slash colon slash, which is greater than 1960. I will put here. So the result, so the published year of the books, which is greater than 1960, I will get those results. So let me hit the query, and here you can see I am getting only one result. And if I show you the collection 1960, 1949, 1851, so 1960 we have only one. But if I put here the 1950, so I'll get more result. So here I have two results, 1960 and 1951. And if I put the 1940, I will get more result. So by this way, you can get any query, you can put any query or filter in the GraphQL API. Okay, so that's it for this video. I hope you liked the video. If you liked the video, please hit the like button. Please subscribe to my channel and keep watching. And you can comment whatever you need on the GraphQL microservice. I will extend this series, the GraphQL things, and I will make another video on the GraphQL. Okay, thank you.